Egg Amazing students! I am teacher Christine, and today we are going to find someone who is willing to be part of our Egg Amazing activity. So let's go! Hi sir!
Hello,
What's your name?
I'm JJ de la Cruz.
So I have a question. Do you believe in magic?
Yes, I love watching magic tricks.
That's good to hear. So do you mind joining me to do an Egg Amazing activity?
Yes, sure.
So come!
Get a clear glass, a bond paper with an arrow facing to the left, and a water.
Alright, so what do you think will happen when this arrow is placed behind the clear glass?
I guess the direction is still the same.
Okay, so let's see. You guessed it right, so it is still in the same direction. But what if we put a water in a clear glass? What do you think will happen?
I think there's no changes at all.
Okay, so let's see. What have you noticed?
Wait, there is such changes with the direction. What happened?
This phenomenon is what we call refraction. Refraction is the process of bending of light when it passes from one medium to another, such as from glass to water. Light travels at speed of 3 times 10 raised to 8 meter per second in vacuum, but when it travels from a denser medium such as water, it slows down, making the direction opposite. And oh, by the way, it's not magic, it's science.
It's so wonderful here.
Do you want to take a picture here?
Yeah, sure.
Come on. Okay. 1, 2, 3, smile. One more time. 1, 2, 3.
Can I see? Wow, the advancement of technology nowadays is getting more exciting.
Yes. Just like in a few years ago, we can only zoom in and out the picture or video. Now there are many ways to take a picture, just like the 0.5. We can take the picture in a wider view.
Absolutely amazing, right?
Yes.
Let me share something with you. The capturing of objects and the eyeglasses that we use for reading uses a lens. A lens is a piece of transparent material or glass that helps us see the image of an object larger or smaller. In a sphere, the one which is curved outward is what we call the convex lens, while the part which is curved inward is the concave lens. For you to remember it easier, let's use our hands to illustrate their shapes. Put your hands like this, and the inward curve is the concave lens, while the outward curve is the convex lens.
What does their shape do with how can we see the image?
That's a good question. Come and let's have a virtual experiment.
Hi guys! Welcome to the lab lens. Oops! This is not the proper attire during laboratory experiment. Let me change into a proper one. Alright, we are now wearing our laboratory gowns, shoes, and our hair are properly tied, and we don't wear any accessories. Before anything else, we must always remember the laboratory rules. Do not play with the materials, especially we are going to use candle and fire, which may cause harm. Now, let the activity begin. Today, you are going to uncover the images behind the lenses. You may copy this table to serve as your guide in taking note of your findings in the activity. I have here a convex and a concave lens, a candle, a lens holder, a cardboard, and the two major important points in the lenses, which are the center of curvature and the focal point. The focal point in our activity is 15 cm and the center of curvature is 30 centimeter. We are going to use first the convex lens. So we are going to place this convex lens on a lens holder and place it 15 centimeter away from the focal point. Then we are going to light this candle up. Let's turn off the light first to see the image better. Alright, so if I place this candle far from the center of curvature, what will you notice in the image on the board? What is the orientation, the type of the image, size, and location? On the other hand, if we put the candle between the center of curvature and the focal point, what can you observe? Are there any changes with the image orientation, type, size, and location? In the third case, if we put this candle exactly at the focal point, what have you noticed with the type of the image, the orientation, size, and location? In the last case, if we put this candle at the middle of the convex lens and the focal point, what observation will you get? Does it have any image on the board? Compare it with a concave lens. Now that we're done with the experiment, let's see if your answers are correct. A convex lens is thicker at the center and thinner at the side. It is also known as converging lens. Do you have any idea what the term converging means? Convergence means to meet at a certain point, meaning to say, in the convex lens or converging lens, the ray of light tends to meet at a certain point where the image is located. In the activity a while ago that we did, using a convex lens, we saw an image of the candle on the board when the candle is placed far from the center of curvature. in between the center of curvature and at the focal point. This means that the convex lens can form a real image.
But wait, how come the image on the bird seems upside down?
It is because of the way light rays bend when passing through the lens, causing the light from the top of the object to be refracted towards the bottom of the image and vice versa. On the other hand, did you see an image on the board when we placed the candle between the focal point and the convex lens? None? Well, it only means that a convex lens can also form a virtual image. And take note of the virtual image. It is highly enlarged and found on the same side of the object. It is also upright. Take note of this. The convex mirrors are used by humans to help them see the object in a bigger size, such as the magnifying glass. Now, let's move on to the concave lens. A concave lens is thinner at the center and thicker at the sides. It is also known as diverging lens. If the convergence means meet at the certain point, what does divergence means? From the word itself, divergence, the ray of light tends to move away from each other. The reason why no matter what we do onto the candle's location, we can see any image on the board. And the type of the image seen in the concave lens is always virtual. The concave lens is used by humans to help us see the object to be smaller than its actual size.